You want to know something that genuinely keeps me up at night? Not the unsolved problems, not the equations that don't balance. What keeps me up is the people who think we've already found the loopholes. I've spent my entire life loving physics, genuinely, embarrassingly, unreservedly in love with it. The way an equation snaps into place, the way nature always turns out to be more surprising than the cleverest thing any human ever imagined. I love this subject so much that I refuse to lie to you about it. And here is the lie that is eating science fiction, eating popular culture, eating the dreams of a million brilliant young engineers who deserve better. The lie is this, that faster than light travel is just an engineering problem. That someday some genius in a lab, maybe you, maybe your grandchildren, is going to crack the right equation, build the right machine, and suddenly the stars become neighbors. That's the story we tell ourselves. And I understand why. I do. Because the alternative is almost too heavy to carry. But I have to be honest with you. When I look at what physics actually says, not the pop science version, not the Hollywood version, but the cold, structural bedrock of what we know about reality, I see something that most people are not ready to hear. Faster than light travel isn't just hard. It may not be a question of engineering at all. It may be a question of whether reality itself permits it. And today, I'm going to show you exactly why. Not with hand-waving, not with, well, nobody knows for sure, with the actual physics, the real math, the verdicts that come not from opinion, but from the structure of space-time itself. By the end of this, you are going to understand something that most physics professors won't say out loud in a lecture hall, because it sounds too final, too bleak, too much like closing a door that humanity desperately wants to keep open. The universe may have written FTL travel out of the script before the first star ever ignited. Let's find out why. Let me start with Einstein. Not because it's fashionable, but because the man did something almost nobody does. He followed an idea all the way to the end, no matter how uncomfortable the destination. In 1905, Einstein asked a simple question. What if the speed of light is the same for every observer, regardless of how fast they're moving? It sounds like a small assumption. It sounds almost boring. It is, in fact, the most catastrophically consequential assumption in the history of human thought. Because when you follow that assumption all the way to its logical conclusion, you don't get a minor correction to Newton's laws. You get a complete restructuring of reality. Space and time are not separate things. They are one thing, space-time, and they bend, compress, and stretch, depending on how fast you move through them. Now here's the part people gloss over. They hear the speed of light is the cosmic speed limit, and they nod and they move on. But they don't really absorb what that means. So let me make it visceral. Mass is not a fixed property. It is a relationship with velocity. As you accelerate an object, any object, a spaceship, a proton, a grain of sand, its relativistic mass increases. Slowly at first, barely noticeable at 10% of the speed of light, still manageable at 90%. But as you push toward 99%, 99.9%, 99.9% of light speed, something terrifying happens. The energy you pump into the ship stops translating into speed. It starts translating into mass. The ship gets effectively heavier, which means it needs more energy to accelerate, which makes it heavier still. It is a feedback loop with no exit. To reach exactly 100% of the speed of light, a ship with any mass at all, would require an infinite amount of energy. I don't mean a lot of energy. I don't mean more than a star produces. I mean a number that doesn't exist on the number line. Infinity. Not achievable by any civilization, however advanced, because infinity is not a very large quantity. Infinity is a category error. It is the universe's way of saying this door is not just locked. There is no door. And before you say, well, what about massless particles? Yes, photons travel at light speed. They do it because they have zero rest mass. Your spaceship does not have zero rest mass. Your spaceship has seats and coffee makers and human bodies filled with water and carbon, and every single gram of that is a vote against you. Special relativity isn't a rule that applies until a clever engineer builds a better engine. Special relativity is the geometry of space-time itself. Breaking it would not be an achievement. It would be equivalent to drawing a triangle with 4 sides and calling it progress. Now, some of you are already formulating your objection. You're thinking, fine, we can't reach light speed. But what about going around it? What about wormholes? What about warp drives? What about quantum entanglement? I love this instinct, I genuinely do. The desire to find the side door when the front door is welded shut, that is the engineering mindset, and it is a beautiful thing. But I need to show you what is actually at stake when you try to go faster than light. Because the problem isn't just speed, the problem is causality. In our universe, cause comes before effect. You push a domino, it falls. The push is the cause. The falling is the effect. The cause always precedes the effect. And this is not a coincidence. It is a structural law baked into the geometry of space-time. Now here is the nightmare. Special relativity has a feature that most people don't spend enough time with. The sequence of events. The question of what happened first is not absolute. It depends on the observer's frame of reference. For events separated by a space-like interval, different observers moving at different velocities will genuinely disagree about which event happened first. This is not a measuring error. It is a feature of how space-time works. Under normal circumstances, this is fine, because no signal and no matter can bridge those space-like intervals faster than light. Causality is preserved. But the moment you allow faster-than-light travel or faster-than-light signaling, this protection evaporates. If you can send a message or move a ship faster than light, then there exists a valid reference frame from which that message traveled backward in time. Not metaphorically, not in a from a certain point of view sense. Literally, mathematically, unambiguously. And if you can send information or matter backward in time, you can construct scenarios where an effect precedes its own cause, where a signal arrives before it was sent, where you can in principle prevent the very event that caused you to send the message in the first place. This is not a philosophical puzzle. This is a mathematical proof that FTL implies time travel, and time travel implies the collapse of causality. And the collapse of causality means the universe cannot have a coherent history. The reason the speed of light is the cosmic speed limit is not arbitrary. It is the speed at which the laws of cause and effect stop working. The universe is not being unkind to us. It is maintaining the basic logical structure that allows anything, stars, chemistry, life, memory, love, to exist at all. If you break the light barrier, you don't get a faster civilization. You get a universe where nothing means anything because effect no longer requires cause. Now I know what the optimists in the room are reaching for. Miguel Alcubierre, 1994, the warp drive paper. I have to give Alcubierre enormous credit. It was a genuinely ingenious piece of mathematical creativity. He found a solution to Einstein's field equations, the equations of general relativity, that describes a bubble of flat spacetime moving through the universe faster than light. The ship inside the bubble doesn't move relative to the space around it. The space itself is contracted ahead and expanded behind. No local violation of special relativity. No infinite energy for the ship itself. On paper, it is beautiful. And for about 10 years, the people who wanted to believe in FTL travel pointed at that paper like a torch in the dark. But then people did the math. The energy requirements are not merely impractical. They are physically catastrophic. Early calculations estimated that a warp bubble the size of the Voyager probe would require the energy equivalent to the mass energy of Jupiter, an entire planet, converted completely to energy via EMC quadrate, just to power a bubble smaller than a school bus. Later refinements brought that number down and then back up again, depending on assumptions, but the floor of every serious calculation sits somewhere between the mass energy of a large planet and the mass energy of the entire sun for a tiny ship, moving for a limited time. And even that isn't the most damning problem. The most damning problem is this. To create the warp bubble, you need exotic matter, matter with negative energy density. Not just negative charge. Negative energy, matter that gravitationally repels other matter. We have never observed this in nature, in the quantities required. The gap between what any known quantum effect produces and what an Alcubierre drive requires is not a gap you bridge with better manufacturing. It is a gap of many orders of magnitude, and we have no evidence that the required exotic matter is physically realizable. But here is what truly kills the dream. The interior of an Alcubierre bubble is causally disconnected from the walls of the bubble. The pilot inside cannot control the bubble, cannot steer it, cannot turn it off, cannot even send a signal to the bubble walls to manipulate its shape. You would build your warp bubble, set it in motion, and then be a passive passenger with absolutely no ability to stop or steer until the bubble naturally collapses, which it will do unpredictably because you cannot control it from inside. This is not an engineering challenge waiting for a clever solution. This is a structural problem embedded in the mathematics of the solution itself. What about quantum entanglement? I hear it every single time. And I want to be careful here, because entanglement is genuinely one of the most wonderful and strange features of quantum mechanics, and I do not want to dismiss it. But I need to correct a misunderstanding that has spread so far and so deep that it is now in textbooks written by people who should know better. Quantum entanglement does not transmit information. Yes, two entangled particles can be separated by any distance, and when you measure one, the other instantaneously assumes a correlated state. This is real. This has been confirmed experimentally to extraordinary precision. Einstein called it spooky action at a distance, and he hated it, and he was wrong to hate it, because nature simply does not care about Einstein's aesthetic preferences. But here is the critical detail. The result of your measurement is random. You cannot choose what state your particle collapses into. You get a random outcome. Your entangled partner also gets an outcome, instantly correlated with yours, across any distance, but neither party can control what outcome they get. Neither party can encode a message in the randomness. And without the ability to send a classical signal, a regular slower-than-light communication to compare notes, neither party can even confirm that their results are correlated. The correlation only becomes visible when you compare measurements after the fact, using ordinary slower-than-light communication. Entanglement is not a communication channel, it is a correlation, and correlations cannot carry information. The no-communication theorem in quantum mechanics proves this rigorously. You cannot use entanglement to send a single bit of information faster than light, not with current technology, not with any future technology, because the mathematics of quantum measurement does not permit it. The universe, it turns out, is very thorough about protecting causality. It closes every loophole, every single one. Let me step back now from the specifics and show you the larger pattern. Because there is a pattern here, and once you see it, you cannot unsee it. Every time a physicist finds a mathematical mechanism that might permit FTL travel, the universe sends back an audit. And the audit always finds the same thing. Wormholes. Theoretically possible, but they collapse faster than light can traverse them unless you prop them open with exotic matter. And even if you could hold one open, a traversable wormhole would function as a time machine, which creates causal paradoxes, which means quantum effects would almost certainly destabilize and destroy the wormhole before any paradox could complete. The universe apparently has error correction built in. Tachyons, hypothetical particles that travel faster than light. If they existed, they would have imaginary mass, which means the math describing them is not describing a real particle in any sense we understand, and they would produce causal paradoxes. So far, tachyons remain hypothetical in the truest sense of that word, a mathematical curiosity without a single shred of experimental evidence. The pattern is always the same. A door appears, you run toward it, and as you get close, you realize it is painted on the wall. Now, I promised you honesty, and honesty requires me to say this. We do not have a final proof that FTL travel is impossible. Physics does not work that way. We have models. Our models have been extraordinarily successful. Special relativity has been tested to extraordinary precision. General relativity has been tested to extraordinary precision. Quantum mechanics is the most precisely verified theory in human history. And every single one of these frameworks independently converges on the same answer. FTL means causal paradox. FTL requires infinite or exotic energy. FTL is geometrically incoherent. Could there be physics beyond what we know? Of course, there must be. The universe is under no obligation to have already revealed every secret to us. But the burden of proof for FTL is not, we haven't disproven it. The burden of proof is evidence. And right now, after more than a century of the most precise physical measurements in history, every arrow points the same direction. I want to end on something true, not comforting. True. When people first understand that FTL may be genuinely impossible, not just hard, but perhaps permanently, structurally closed, they feel something that I think is important not to rush past. A kind of grief. The stars that were neighbors a moment ago recede back to their actual distances. Hundreds, thousands, millions of light years, unreachable in a human lifetime. Possibly unreachable for any civilization ever. Let yourself feel that. It is the appropriate response to a large truth. But now let me show you the other side of it. Because there is always another side, and it is the side that made me fall in love with physics in the first place. The speed of light is not a cage. It is a consequence. It is the consequence of the fact that causality is real, that effects require causes, that history is coherent, that the universe has a consistent story. The same law that prevents you from reaching Proxima Centauri in an afternoon is the law that prevents your past from being rewritten. It is the law that makes knowledge possible, because knowledge requires that experiments have repeatable outcomes, and repeatable outcomes require a universe with consistent causal structure. We are not trapped. We are participants in a universe that has rules, and rules, unlike chaos, can be understood. The stars are far away, possibly permanently, finally, unreachably far, for anything made of matter and wanting to arrive in one piece. And what we do with that fact, whether we build telescopes and detectors and mathematical models of extraordinary beauty to understand what we cannot touch, says everything about what kind of species we are. I have spent my life looking at the universe and finding it more surprising, more beautiful, more strange than I expected. Not more manageable, more strange, and I am glad of that. The universe doesn't owe us a shortcut. It doesn't owe us neighboring stars or galactic highways or warp drives we can build in a garage. It owes us nothing, but it gave us physics. It gave us the ability to look at a universe we cannot travel and understand it anyway, to hold a galaxy in an equation, to find the rules that bind even things we will never touch. That is not a consolation prize. That is the whole game. Keep doing the math. Follow it all the way to the end, no matter where it takes you, even when it takes you somewhere you didn't want to go. Especially then,